Hello again, class. This is another video tutorial of probability focusing on and, or, at most, or at least, and not events. So let's take the experiment of an 8-sided dice. With almost all probability experiments, we should make the sample space. So we'll do our sample space here. So the results that can happen with an 8-sided dice are 1, 2, 3, 4, 5, 6, 7, or an 8. Okay, so now we're going to go straight into and or events. We'll begin first with and. So with and events, we find only the common elements in both events. So let's take a look at what we mean by that. So let's take the probability of even and multiple of 3. So as we can see, there are actually 2 events happening at once. Well, 2 conditions at the very minimum. We have evens and multiple of 3. So let's label each of them, just make it a little bit easier. We'll label this group A, or condition A. Label this group B. Okay, so we'll start with group A. What numbers belong in group A? If they want to be even, well then it has to be 2, 4, 6, or 8. So it's going to be 2, 4, 6, or 8. Now for group B, they want multiples of 3. Well then there's a 3 and there's a 6. There's no 9 because it stops at 8. There's only an 8-sided dice. So it's only going to be 3 and 6. And then now, so these are each group individually. But if we want A and B, so now let's find the numbers that are common to both of them. Well, 2 is not common, 4 is not common, 6 is common, so we'll put that in there. 8 is not, 3 is not, it's only 6. 6 is common to both of them, which gives 1 outcome. Oh, I forgot to add here, there are 8 total here, 8 total outcomes, which means the probability of even and a multiple of 3 will be 1 outcome, which is what we just counted and calculated here, out of 8. So that gives us 1 out of 8. So that's and. So we'll do just another example just in case we'd like to emphasize our learning here. We'll do another one. Probability of multiple of 2 and multiple of 3. So once again, we have 2 groups. We have group A here and group B, or condition A and condition B. So let's start off with condition A. Multiples of 2. So Well, then we have 2, 4, 6, and 8. 2, 4, 6, and 8. And multiple, actually, just so that we can see what happens, we'll change this one to a multiple of 5. Sorry for changing that on you. Multiple of 5. Let's go with condition B. So which ones are a multiple of 5 from our sample space? Well, there's only one. It's 5. 5 is a multiple of 5. So now we're going to do A and B. So which numbers are common to both of them? Well, I hope you can see there is none. 2 is not common, 4 is not common, 6 is not common in both, 8 is not common in both, 5 is not common in both. So this is what's known as a null. That's a special symbol for us. It's an empty group. So this is 0 outcomes. Well, so then the probability of getting a multiple of 2 and a multiple of 5, I should put it here, but running out of space, is actually 0 out of 8, which is just 0. Because really, think about it. Which numbers are both a multiple of 2 and 5? Well, the first one that we can think of is 10. But there is no 10 in our sample space. So let's continue now on to OR. OR. The OR condition is we combine both groups without double counting. I'll teach you in a bit what double counting means. Okay, so we'll take the exact same one, probability of even, but this time I'm going to change it to OR. So we're going to make it probability of even or multiple of 3. Not multiple of, we'll just multiple 3. Not multiple of. Multiple of 3. Once again, we have two conditions, A and B. I'm not going to label them anymore. We'll just leave it as A. Well, evens. Let's pretend we haven't done it already. I know it's there. Let's pretend it's not there. Evens from 2 to 8. Oh, from 1 to 8, sorry. It's going to be 2, 4, 6, or 8. And once again, B, the multiples of 3. Well, there's only 3 and 6. So now we're going to combine both A or B. We're going to combine both, but take a look. See how 6 is common in both? If we were to combine both of them, we would get something like this. I'll do it in pencil first. We would go with, we would get 2, 3, 4, 6, 6, and 8. However, the 6 only happens once in the sample space. There aren't 2 6s in the sample space. So all we did here is that 6, since it belongs to both, we're accidentally double counting them. So we're just gonna not, if we've already counted it once, we don't count it again. I'll just finish it off with pencil. That's 8. Okay, so there's, make sure we don't double count. The way I do it is I just cross off it once. That way I don't count it again, which gives us 1, 2, 3, 4, 5. That is 5 outcomes, which also gives us a probability of an even or a multiple of 3, gives us 5 out of 8. Let's go with another one. We'll go with a probability, same thing as above. The probability of a multiple of 2 or multiple of not 3 of 5, or this time. So again we have A and B. We'll go with A first. Multiple of 2, sorry. Multiple of 2 is 2, 4, 6, or 8. The multiple of 5, where there's only 5. And this time we're going to combine both of them, A or B. Well, this time there's no double counting because they're all unique. 2 happens once, 4 happens once, 6 happens once, 8 happens once, 5 happens once. So it's going to be 2, 4, 5, 6, 8. So that's 1, 2, 3, 4, 5. That's 5 outcomes, which gives a probability of 5 out of 8. And that is and or conditions. We'll now do the conditions of at most or at least. At most or at least. The easiest way I remember it is at most means at most is no higher than, and at least is no less than. Okay, so by that I mean we're going to continue with the 8-sided dice. So I'll just write here that we're going to 8-sided dice, and I'll write the sample space here. We have 1, 2, 3, 4, 5, 6, 7, and 8. So at most, so let's say we have a probability of at most of 4. I almost did a squiggly bracket there. So we have the condition A. So here's A. So we're gonna start counting but stop at 4 because at most means no higher than 4. So let's start counting the sample space here. It's gonna go 1, 2, 3, 4. And we stop there because it says no higher than or at most a 4, which gives us 4 outcomes. So the probability of rolling at most a 4 on an 8-sided dice is 4 out of 8, which is 1/2. And I think you can see where this is headed towards. So at least, so we do the same thing, probability of at least 4. Same thing, we have the group A. That's A here. Okay, at least the 4. So we're going to start at 4 because it's no less than 4. That means the smallest number we start at is 4 and start counting up. 4, 5, 6, 7, and 8. Which gives us 1, 2, 3, 4, 5. That's 5 outcomes, which gives us 5 out of 8. And just letting you guys know, these only apply to numerical sample spaces. Numerical sample spaces. So if we take, for example, a sample space that only contained boys and girls, it makes no sense to say at most a girl, or at most, or at least a boy. That makes no sense. It only makes sense on numerical sample spaces. These are numbers, so it's a numerical sample space. And at the very last, we're going to look at the not condition. Not condition. Now, to make more sense of this again, we're going to stick with the sample space, same sample space of an 8-sided die. So the not, take for example the probability of rolling an even number. Okay. So let's write up the numbers that fulfill even. So we'll get group A again. Remember, we can label these anything, but I always start with A just to make it easy. So evens are going to be 2, 4, 6, and 8. Okay. So obviously we have the probability of 4 out of A, which is 1/2. Now, here's what it would look like if we calculate the not even. So it will look like this: probability of not even. Okay, well, let's pretend we haven't calculated this. We haven't counted this group yet. So let's do that now. So we have A. So first we ignore the not. And we just find evens. So A is even. So that is A, even. So the evens are going to be 2, 4, 6, and 8. Okay. Now the not looks like this in mathematics. It has a dash. And what the not event means is we take every other number that is not in this event, in this group here. So if we take a look at a sample space, the 2 is in the group, the 4 is in the group, there it is, the 6 is in the group, and the 8 is in the group. So the numbers that are not in the group, so not even, because here are the evens, we want the not even. So it's going to be 1, 3, 5, and 7. So it's going to be the 1, 3, 5, and 7. So that gives us 4 outcomes. That gives us 4 out of 8, which is 1/2. And if you think about it, what is not even? Well, that is the same as finding the odds, isn't it? Not even is the same as finding an odd. We'll take another example. We'll take the probability of rolling a 1, 2, or a 7. So that is our condition, 1, 2, or 7. So now let's take a look at the group A. Kind of silly, I know, but it's 1, 2, and 7. Which numbers fulfill 1, 2, and 7? Well, it must be 1, 2, or 7. So now let's find the group of not this. So which numbers are not 1, 2, or 7? Well, 2 is there, 3, 4, 5, 6, 7 is there, and an 8. Now you take a look. So if this is the probability of 1, 2, 7, which will give us 3 outcomes, that's 3 outcomes. Oops, that's 3 out of 8. But if we found the probability of not 1, 2, or 7, it would be 1, 2, 3, 4, and 5, which is 5 outcomes, which gives us a total of 5 out of 8. And I hope you see something interesting about the event and the not event. Okay, so the event is, so if we have the, we'll do it in black, if we have the probability of some event, and we add the probability of the not of the same event. So if we find an event and find the not event and you add the probability, it will be 1. So just take a look. Take a look at this one. Probability of 127 is 3 out of 8. So we'll put that here. 3 out of 8. So that's the A event. And if we add the not A, because here's A, here's not A, that's going to be 5 out of 8. Well, 3 out of 8 plus 5 out of 8, that's equal to 8 out of 8, which is the same as 1. And the purpose of learning this is, let's say we have a sample space. Let's say we have a sample space that contains, say we have a sample space that contains 100 things. So it's going to be 1, 2, 3, 4, 5, up until 99 and 100. Okay, if they told us to calculate the probability of what's it called? We'll say of not 3, 5, 7, 11, 13, and it's, I don't know, 17. Rather than list, so because look, here we have the group, that's A, so here we have A. So the numbers that fit this category, that fit this event, are 3, 5, 7, 11, 13, and 17. The not A, there is no way in hell am I going to list everything here. I'm not going to list 1, 2, 4, 6, and so on. Instead, I'm just going to go, okay, this is 3, 5, 7, what's 1, 2, 3, 4, 5, 6, that's 6 outcomes. Okay, well, if you do 100, which is all of it, minus 6, so this would be equal to 100 minus 6, which is 94. There'll be 94 outcomes left. So this will give us 94 out of 100. That's the reason. See that thing that we showed you? The reason why we do this, it makes this calculation much easier. I wasn't about to list everything else here. We just do the total minus the A event. And finally, these are what's known as complementary events. So A plus not A equals 1. These events are called complementary. So for example, if I have a probability of 1 over 3, the complement, so let's say we have probability of E is equal to 1 over 3. The probability of not E is 2 over 3, and these two, since they add up to 1, these are called complementary events. That concludes the video.